Sound of someone struggling to do push-ups, grunting. Alright, picture this. You're a grad student in Dr. Christian Éthier's lab. You're ambitious, you're smart, but maybe you're not a morning person. You roll in a little late one day, and Dr. Ethier, this brilliant but incredibly intense neuroscientist, looks at you. There's no lecture, no disappointed sigh. Just a simple command, down, give me push-ups. So you get down on the floor. But here's the thing, your form is just awful. Your elbows are flaring out, your back is sagging. It's a mess. He watches you struggle, and you can practically see the gears turning in his head. He's not just seeing a student who needs to hit the gym. He's seeing a problem of motor control, a performance deficit. And in the Éthier Lab, a performance deficit isn't just a weakness, it's a research opportunity. This is where things get wild. Instead of just suggesting a better workout plan, Dr. Ethier gets this glint in his eye. He starts talking about enhancing your performance, not with caffeine or a better pre-workout. No, he's thinking bigger. He's thinking, what if we could directly boost the part of your brain responsible for movement? He starts sketching on a whiteboard, talking a mile a minute. The idea? A closed-loop brain implant. This isn't just some sci-fi fantasy. This is his actual research. He wants to design a tiny, sophisticated device that sits right on your motor cortex, the brain's command center for movement. This implant would monitor your brain activity in real time. The moment it detects you're about to make a move, like starting a push-up, zap, it would trigger a targeted release of dopamine. Why dopamine? Because it's the brain's ultimate good job chemical. It's all about motivation, reward, and reinforcing actions. The theory is, by giving your brain a little dopamine hit every time you execute a motor command correctly, you could learn faster, move more efficiently, and basically become a push-up machine. He's not just trying to fix your form, he's trying to supercharge the very learning process in your brain. Now, before you start picturing a lab full of cyborg grad students with wires coming out of their heads, there's a crucial step. You don't just go from a whiteboard sketch to human trials. Dr. Ethier, being a responsible and maybe slightly mad scientist, knows this. So who are the first test subjects for this revolutionary performance-enhancing brain implant? Whispering. The rats, yes. Before this tech ever gets near a student, it has to be perfected on our furry little lab mates. The lab has these tiny rat-sized setups where they test the implants. They're training rats to perform specific motor tasks, and when the implant works, you can literally see their performance improve dramatically. It's the ultimate proof of concept. They're refining the algorithm, checking for side effects, and making sure the dopamine boost actually leads to better, stronger movements. So yeah, the vibe in the Éthier Lab, it's one part cutting-edge neuroscience, one part high-intensity personal training, and one part, well, a little bit terrifying. You might show up late and end up inspiring the next generation of brain-computer interfaces. And you can bet that every time you see one of those rats acing its task, you'll be thinking, that could be me one day. And you'll make damn sure your next set of push-ups is perfect.